What if the very systems that once limited aerospace innovation are now being dismantled by the cloud? Let's explore how Tim's transition is bridging two critical worlds. Welcome to the first segment of our deep dive into the aerospace industry's digital transformation. Today, we're joined by Tim Murnin, a seasoned professional whose journey from Boeing to AWS is really an example of the convergence of traditional aerospace expertise and cutting edge cloud technology. Tim's trajectory offers a unique perspective on how our legacy aerospace companies are embracing digital solutions to enhance efficiency, reliance, and innovation. His insights will shed light on the challenges and opportunities that come with integrating cloud technology into an industry known for its complexity and precision. So, Tim, first of all, maybe give us a quick introduction. Who are you? Why are you here?
Yeah, nice to see you, John. So, as said, my name's Tim Murnin. I lead our aerospace as well as our high-tech electronics and semiconductor industry solutions team at AWS. So, I've been here about 4.5 years now after about 16 years at Boeing in a variety of supply chain roles. So, I came out of the business side of Boeing where, really we created one of the first integrated supply chain organizations, not just at Boeing, but in the overall aerospace industry itself. Prior to that, I spent a lot of time in consulting and with various other technology companies, including what used to be Manugistics, now part of Blue Yonder. So my background in supply chain spans multiple industries, but the bulk of my time has been with aerospace.
It is, and it's great. It is great seeing you again, Tim. It genuinely is. And for those that don't know, Tim and I, we've had a great relationship over the years in AWS. So it's fantastic to have this chance to join him in in a more informal setting and just get some of these insights out of him. But that doesn't mean we're not going to be interrogating you, Tim. So stand by for some questions. So look, I mean,
I'm
the
always
thing I
prepared for your challenges.
the thing I always loved about whenever you and I have been talking is, you're able to sort of bridge that notion of the whole strategic down to the tactical. You've got a real detailed understanding of what's happening, under the hood in aerospace. So maybe you can help by unpacking how some of those traditional aerospace experiences have shaped your approach to digital transformation in the cloud.
Yeah, I think one of the key things to think about, and it might go without saying, but everything in aerospace gets linked to the airplane that's coming out the factory door at the end of the day, or the airplane that's being delivered to the customer, or the airplane that's in flight. So whenever we think about digital technologies or the cloud or anything else, we always anchor that thoughts on how does it benefit the airplane? How does it benefit the business? So, there's a lot of focus around cloud and AI and various technologies today, but there's not room in aerospace to look at cool for being cool. You really need to anchor it in what is the business value and how does it help the program manager or the pilot or the passenger experience improve what they're trying to do at the end of the day. So my background in supply chain, one of the biggest challenges we always had was trying to understand what supplier performance was going to be. So whereas in an organization like CPG, you're very focused on demand forecasting of finished goods delivery. Well, in the aerospace industry, you kind of know how the plane gets delivered to the customer at the end of the day. So what you're focused mostly on is backwards looking in terms of what are the requirements you're putting into the supply base, what are the risk factors in the supply chain, and how do you start to address those? And technologies like the cloud and like AI really start to unlock opportunities in those things that we haven't seen before.
So I think it's really interesting perspective, and one of the advantages of your previous life as a consultant as well is that you'll have looked at lots of different industries. And the advantage of sitting in AWS, of course, is that you also get to see how lots of different industries are applying cloud technology. So maybe if we could sort of double tap for those not familiar with aerospace, what are the challenges that are uniquely aerospace, or what are the solutions that cloud is solving that are uniquely or particularly valuable to aerospace customers?
Yeah, thanks, John. So I think a couple of things that distinguish aerospace, particularly from large scale industrial manufacturing and in other ways, is first of all, when you think about the types of volumes that are going through an airplane factory, we're talking about what are relatively low volume, low mix operations lines. So even if you take a production line like the A320 at Airbus, which they're hoping to get to 75 aircraft a month in the next couple of years, that's still on a relative scale, a really low volume of manufacturing that's going through. So when you're thinking about things that might pertain to a lot of manufacturing, things like OT technology and edge work and things that are happening where you're monitoring factory performance from a machine perspective, well, I won't say that doesn't have any applicability at aerospace. It's much less important than understanding what are actually happening in terms of the manufacturing floor, in terms of part shortages, labor issues, safety issues that may be coming through. And that's really what spans top of mind. So what we focus on from the industry perspective is how do you integrate data from all of those disparate systems that are coming from different places into a single environment so that whether the head of manufacturing or the program manager has a common visibility layer for where they are. Because the other thing to keep in mind from the aerospace industry is it's a highly regulated industry, whether we're talking about commercial aircraft or defense aircraft. And most companies have a lot of restrictions on the ability to share data, leverage data, whether that be from a regulatory perspective and things like ITAR or GDPR or Gaia X, and how different countries and different regions of the world have to secure their data. But even internally, they may have very strict policies around, for example, who can see data related to a particular supplier performance. That you may only be able to access that system if you're part of the procurement team, for example. But at the end of the day, if you're a mechanic on the shop floor who has a missing part, you need to understand where that part's coming from and what the delivery schedule is. So the things that we try to do is overcome those barriers, not by violating those data security and data sovereignty issues that are out there, but by respecting what those things are, but also providing visibility at the point of use for where people need to solve problems that leverage that data.
So I think it's, I mean, so again, very data heavy, but and also, if I can say, it's strategic in terms of our wider understanding. So maybe I can ask for something a little bit more, in the woods, as it were. So can you give us a specific example, regardless of defense, US, EMEA, whatever, a place where AWS has come into the aerospace industry, is dealing with a client and helping them overcome a specific supply chain challenge?
Yeah, so we're working with a customer right now who's a large OEM today, and exactly that same challenge. So one of the things they need to understand is at when I leave the day, when I'm a shift supervisor or I'm the head of manufacturing, did I win the day? Did I produce what I said I was going to produce? And so if you go into an average airplane factory, what you'll see on the floor tends to be you have a 6 a.m. morning meeting where all the staff comes together. There's usually a flat screen that has some sort of static display chart that might be Excel, it might be PowerPoint that basically says, here were the overnight metrics. There's a bunch of manually printed sheets around that show things like state safety recordables, non-conformance issues, things like that, that the factory has typically brought together an army of industrial engineers to assemble and put those things together so that people can have a briefing for it. What we've done is looked at putting a system together that says, how do I understand, no matter who I am, again, whether I'm the first line supervisor, whether I'm the head of manufacturing, what is being produced in that factory, and how do I click through at each one of those workstations? So, for example, if I'm sitting in a cell and I want to understand what the performance is, how do I have a view that shows me every individual worker on that cell line? If I see and how is their individual performance? So, if I see that one particular person maybe their efficiency is less than what our expected standard is, I can click through and maybe I can find out, you know what, they're relatively newly trained to the operation, so they don't necessarily have the background. They need a little more coaching. They need some things. Maybe there's an absenteeism problem that might be able to go through there. But it's not just around the visibility of that data. The next thing we want to do is provide specific recommendations for when you do have constraints in the supply chain. How do you solve that? And that's where AI comes in. So we start to look at how do we take things like a part shortage and then provide a visibility platform right next to it that where the mechanic can ask an AI engine right on the floor that says, if this widget's missing, when is the expected delivery date? And then what types of things can I do in terms of a workaround? Maybe I can jiggle the order of operations or things like that to allow me to continue down my work path while the part is still being delivered.
So, I mean, if I can scratch the surface of the parts, there's a few other areas I just want to dig into, but thinking about part visibility. So one of the challenges is that, first of all, there's a lot of systems that will enable you to see your inbound flow. So you can determine what volume is in transit. You can determine what volume is currently being held at customs. You can determine what volume may or may not be subject to tariff changes or ITAR and other restrictions that you have. all of which are being impacting the aerospace industry. But one of the challenges often is making decisions around the total cost. So there's lots of things where you can penny pinch, or you could potentially purchase a part a little bit cheaper from a supplier. You could purchase a part a little bit faster and more expensively from another. But seldom do we have the ability to see the total impact of that decision. So what's been your experience in trying to understand and helping businesses be able to understand the total cost impact of a particular option that they go for?
Yeah, and I think one of the things that distinguishes the aerospace industry from others is the um, amount of sole and single source decisions that are going into the actual supply chain. So, it's as opposed to like a retail where you may have multiple vendors for any particular good you're purchasing. If you're buying an actuator, there may only be one qualified source, or there may only be one affordable qualified source to go through things. So, one of the things that we're working on is helping companies in those upfront sourcing decisions. So, where they can start to look at not just cost, but what are the overall risk factors in the supply chain? So, as we're all living through right now, the amount of supply chain risk, whether it be geopolitical risk from, you know, war in Ukraine, whether it be tariffs, whether it be natural disaster opportunities, whether it be suppliers who are financially stressed, the amount of risks that are out there and that have to be managed in the supply chain have really outstripped an individual procurement agent or buyer's ability to manage, particularly when you're talking about a portfolio of projects. So what we try to do is put together an AI environment that allows a procurement agent or sourcing decision maker to look at the type of product they're sourcing, input the type of risk factors that it should consider, and then basically give a scorecard to what the risk level is that is being decided on the sourcing decision. Again, we're not making the sourcing decision for the company. That's still 100% the choice of the buyer, the procurement agent up through that authority. But what we're trying to do is inform them not just of the cost impact, but what is the potential risk that might present downstream hidden costs that aren't there in the upfront decision process.
And so basically helping with the decision support aspects of a fairly complex series of risks and interdependent risks, etc., which is, yeah, is an ideal use of cloud. The other thing that you will do, I'm sure, quite often still, is that we often find ourselves standing in fulfillment centers with customers, and you bring an aerospace customer into an Amazon facility, and they have a chance to see how Amazon works. So you talked about, workers not necessarily having the data during a shift in order to make decisions. Where, as you know, in an Amazon facility, we have by the hour, well, by the minute, understanding of every single process that is being run in the fulfillment center. We can see the variable cost of production for any given SKU. We can make intershift decisions and so forth. And a linked question to this then is, when customers come and see Amazon and they touch Amazon and they get a feel for Amazon, what do you think that sort of culture of innovation and Amazon culture, how does it rub off on the aerospace sector? How do they translate that in a meaningful way?
Yeah, John, I'm glad you brought up culture because I think when we do invite aerospace customers to tour a fulfillment center, sometimes the reaction ultimately becomes, yeah, but what we're shipping is not books and charging cables and things like that. We're delivering highly specialized items, require specialized packaging, and how am I really going to learn or absorb anything there? So when we do bring customers there, it isn't the idea that you can just copy and paste or lift and shift all the operations or the robotics or anything that happen in the fulfillment center into another environment. It really is 100% about culture, and particularly the culture of data. And I think you kind of highlighted there, things like variable cost analysis, but and total cost of ownership. But I think the most important thing is the immediacy of real time data that's presented to a first line supervisor who can see what things are happening. So we brought the CEO of a large aerostructures manufacturer to one of our fulfillment centers about a year ago. And one of the things he was most impressed by is we were kind of walking through and watching an operator who was picking items and putting them into one of our large Kiva robot stow bins. And a manager came over, has a uh, vest on, says coach on the back, and asked what they were doing, and basically had found out through a dashboard that the operator's performance was a little bit slower than what the standard had been expected for. So they were also able to realize this operator was relatively new to Amazon, so they're still learning on opportunities. So they deployed a coach right away to help the person understand, are there issues that we could help somebody recognize things through. And it's that type of immediacy action that allows you to really kind of reflect on what data can unlock for you as a company. And we ended up spending, I think we had forecasted about 2 hours for the tour. We ended up spending more than 6 hours with him as he just really interrogated the use of data, how what it unlocked in terms of innovation, what different things can people do. And when you go through a fulfillment center, anybody who's had an Amazon package delivered, I'm sure will recognize that our packaging has changed. Everything used to come in a very standard corrugate cardboard box. Sometimes people would complain that you might buy an item that's this small and the box is this big. But what we've relied on because of that data is we've been able to shrink the amount of packaging. We've been able to shrink the amount of impact on the environment because we know so much more about form, fit, function of the product being delivered. We'd be able to deliver our own, develop and deliver our own customized packaging for that. And it's those kinds of innovations that really require that type of real-time data analytics and that culture of understanding data and how do you leverage it with immediacy to drive that type of innovation throughout the company.
All right, so companies come and visit. You get to see them all. You've been a consultant before. I'm not going to ask you which is your favorite baby, but I am going to ask
They're
you.
all my favorite.
Of course they are. Every customer is special. I get you. Of all the customers that you're working with, we don't necessarily need names, but maybe, I'm sitting here as a supply chain lead in aerospace, and I'm thinking, interesting, Tim, so far. Who's doing it right? Because we all want to benchmark. Who's out there? What things are being done that are truly, making a difference in the aerospace industry? So, what are those sort of 2-3 innovations that are really driving innovation?
Yeah, let me highlight two companies on opposite ends of the spectrum. I'll say. So from a well-known brand, I think a lot of people understand. Let me highlight Safran in France, and Safran is by all means a legacy company. It's a relatively new brand, but it's the you know evolvement of several other companies that came together a few years ago, and they make everything from large scale aircraft engines to interiors to cabins and lavatories and things like that. And they have really done a fantastic job of putting together a strategic viewpoint of how they move to the cloud. So when you think about their overall global business, they really started with one of their smaller divisions in the US that focused on how do they just do something simple like move storage to the cloud. And this all happened during the pandemic when revenues were really challenged, particularly in the commercial aviation industry. People aren't ordering airplanes, they're not taking delivery of airplanes, which means they're not taking deliveries of galleys and lavatories. So the CIO there had a lot of pressure on him to reduce IT costs. And one of the things he did was just doing something simple like moving file servers into AWS because his perspective was one, it was risk free because if he had an issue of disruption, move it back very quickly. No real issue, no challenge to the business itself. Two, it allowed him to fund other innovations. So he was able to return millions of dollars back to the business through retiring virtual machines, retiring legacy hardware very quickly. So that, the idea of moving file servers to the cloud maybe didn't get the board's attention, doesn't sound all that exciting. But when he's able to return $5 million to the business, suddenly that's a whole different perspective on what the cloud can do. So from there, Safran put together essentially a global council for cloud innovation and where where they want to take the business and where they want to move to cloud that has a very strategic roadmap that looks at by business, what are the types of innovations they want to take on and where do they want to maybe wait and see for things that are more critical to the business and they may roll out things a little bit slower there just to avoid any potential disruption. But their CIO has been a real strong advocate for both the cloud as well as for AWS and pushing those things for where Safran wants to go. The other company I'll talk about is completely on the other end of the spectrum. This is a startup called Beta Technologies, and Beta makes electric airplanes in Burlington, Vermont, over in the U.S. And they're building both a conventional as well as a vertical takeoff aircraft. And one of the biggest challenges in electric airplanes, obviously, is batteries. And Beta is highly focused on battery life cycle management. So they're using AWS to track and trace the origin of every battery from the time it gets manufactured on the line, who works on it, who contributes to it, where an individual battery cell gets installed in a pack, where it gets installed on the airplane, and then to stream performance of the battery live as they're doing their certification and test flights, so they can see how battery consumption is happening and what that means in terms of the overall life cycle of the battery. So it's, here we are at the opposite end of the spectrum of a company is actually developing its airplane, developing its powertrain, and understanding what that may look like through the cloud. So it's exciting on both ends of that spectrum.
Yeah, it's brilliant. Two fantastic examples, Tim. I really appreciate that. In this segment, we're going to delve into the intricacies of aerospace supply chains and how our cloud technology is revolutionizing their management. Aerospace supply chains are among the most complex, involving numerous suppliers, stringent regulatory requirements, and the need for absolute precision. Tim is going to share how AWS is enabling greater visibility, traceability, and resilience in these supply chains. We'll explore real-world applications of cloud solutions that are transforming the way aerospace companies operate, ensuring they can adapt swiftly to disruptions and maintain operational excellence. So, look, Tim, fantastic. Thanks for getting stuck back into this again. So, like we said, we had a good introduction, good general conversation, but now we're going to go deep. So, I really want to understand how our cloud technology is transforming aerospace supply chains. How does AWS enable greater resilience and efficiency in this sector?
Yeah, thanks, John. I think there's one real key issue in aerospace supply chain, and that's really trying to understand what are the risks in your supply chain, where is the potential disruption risk. So, where an average OEM will have really tight relationships with all of its direct tier one suppliers, they'll know exactly who's feeding into their supply chain. That relationship starts to get more and more distance the further you go down into the supply chain, into the level of sub tiers, and what level of visibility do you have for that? And one of the biggest challenges for that is frankly just understanding who those sub tiers are. So who are the suppliers of your supplier? And that data can be problematic because one, the volume of that data gets bigger and bigger as you move forward. Sometimes suppliers may view that as somewhat proprietary and may not want to disclose it, or the OEM may not have relationships with some of those suppliers. So one of the things we're working with customers now to look at is how do you take Gen AI and help you predict and provide proxy data where you may have imperfect visibility today. So again, we're not going to be able to, say with 100% precision tomorrow who all of your third tier suppliers are. But imagine if you had a vehicle that would be able to unlock with 80% certainty that one of those suppliers might be somebody from one of the three companies on this list. And you were able to identify, okay, I know that one of those suppliers sits in the major wildfire corridor in California in November. So I need to reach out to them to understand, A, do they have a disaster recovery plan? Do they have inventory laid on things? Because we've seen this constantly over and over again where one of the things that becomes challenging from a aerospace supply chain perspective is a small company that's embedded into the supply chain that the original order didn't know about, wasn't aware with, but would have been happy to either take action early on or invest in or whatever to make sure that that supplier didn't have the type of disruption they were looking for before. So that's one of the I think, key and most exciting areas we're looking for. And then we're obviously doing a lot of the things that I'll say best practice supply chain companies do in terms of like helping companies establish supply chain control towers and use AI for predictive analytics around those types of fulfillment strategies and things like that for inventory.
Right now, I can't let you get away with two things you've just said there, two massive buzzwords. So I'll put you back on the spot. So here we are. We've got generative AI, every board, everywhere in the world. We all want to go and spend some money on a Gen AI project. We don't know what it is, but we just know that we need it because everybody else has got it, right? So there's a bit of fear of missing out. Now, you've done something that a lot of people can't do, which is to put their finger on a immediate use case, that resonates strongly around the use of Gen AI. So maybe we can just touch it a little bit further. So, for instance, we know that we can use generative AI to help with understanding the end-tier suppliers, and we know that we can use some of that to help with predicting the tariff risk. But the issue can be the data is still being generated from something. So how do you increase explainability, as it were, for that data so that these heavily regulated industries are able to use generative AI in a meaningful and safe way?
Yeah, that's a really important question right now because, as you said, there's a lot of companies experimenting with Gen AI and trying to figure out what they want to do with it. And a lot of them have done basic things like put a chatbot on top of an internal company-wide intranet to help people find internal answers to things like HR problems and things like that. And that's a relatively low risk deployment of Gen AI. What companies start to get a little bit more nervous about is when you put Gen AI out on the direct production line, on things that are customer facing, things that may interact directly with the product itself. So the most important thing for us is when you're leveraging tools like Amazon Bedrock that have full capability for a host of publicly available models, or if you want to bring in your own LLM, you can anchor to that as well. Is that we provide full transparency to what those data sources are. The model, you can ask the models to tell you what it's leveraged for the answer it's providing, and it will provide that right at the user screen. So that gives some reassurance to the user that it's not off using some questionable source and things like that. But more so even upfront when we start to design the RAG architecture or whatever the approach we want to use for Gen AI, we want to anchor that in what are your data security standards, what are your data your proprietary data standards, so that it's only leveraging the data that you've allowed it to do. So, for example, one of the other Gen AI tools that we've been working with a lot of aerospace customers today is a mechanics assistant. So, again, one of the big challenges in supply chain right now is a lot of customers out there have just struggled to hire labor, particularly mechanics and touch labor and people who are working at the airplane itself. So, you have a lot of new employees on the floor who may or may not be all that familiar with aerospace production. So what we've done is provided an environment that allows a mechanic, for example, to take a photograph of a part, put it into a Gen AI engine, and right there it will pull up a service bulletin record of everything that's been done to that part, recommended installation procedures, things like that. But you can see right there that this comes from this particular FAA service bulletin or this job instructions or the PLM data associated with that part, so that again that mechanic has clear visibility into what the source of the recommendation that's coming from Gen AI will allow them to do right there.
It's another absolutely fantastic use case. I love that. Now, one common thing though, you did say control tower, and I'm not going to ask you to give me a dictionary definition of it, but I am going to link control tower to generative AI to all of the other high level supply chain things that we want to do. One of the common currencies is data. And of course, the usual scenario is that poor data in results in poor outcomes, whether it's your generative AI solutions or whether it is your control tower. So maybe you can give us a little bit of an overview, and it's okay to go 101 and then delve it in a little bit deeper. But why is data so absolutely critical to these sorts of strategies that we seek to employ?
Yeah, I think it's really important. I think what we're seeing is a shift in mindset from where companies used to be very application focused. So they talk about, I'm driving my business out of SAP or Infor or Siemens or Dassault or whatever to a much more data centric world. So as opposed to worrying about what the application is that drives that, and all those transaction systems are still critically important, and we still need all those for you know sources of record. But it's how do we provide data at the point of use to the user, regardless of the source system, is really critically important. So when we start to look at any project, whether that be a Gen AI project or anything else, the first question has to be, what is the data strategy that the company has? So what are the policies they have in place around data cleansing, data management, data security, so that we need to make sure that we're, first of all, respecting and allow them to manage data that they want to from their own policy and procedure standpoint, which, like you said, in aerospace, sometimes are a lot more regulated than in other industries. So you have to adhere to what those standards are. So it's really important for us to understand what that data strategy is. So we may spend a lot of time with customers just understanding what are their actual data procedures. And the second area is, particularly in older companies, you have probably 10x more unstructured data that resides in SharePoints and email servers and things like that than does in structured systems. So one of the questions we want to ask companies is, what is the approach you want to take to structured versus unstructured data? Do you only want to leverage structured data for now, or do you also want to take advantage of how do we start to look at all of that hidden data and unlock that environment as well? And we're seeing, a migration, I think, from companies who initially focused exclusively on structured data to now companies asking, well, how can I leverage that unstructured data? What are the types of things I can do that also then provide a lot of guardrails to make sure I don't get in regulatory troubles there or have inadvertent data leakage around those things. So our team works with companies like that to put data strategies in place, whether that be through AWS directly, or we'll work with companies like Databricks and things like that to help them put data strategies in place to leverage that data. But it's the power, like you said, the garbage in, garbage out problem can get amplified as you start to leverage more and more AI and automations techniques around that. So the amount of time we spend with customers understanding their data strategy, understanding the frequency of the updates, how they manage it, and how they govern it is really critical.
Excellent. Now, of course, for a lot of companies, when we talk about data problems, as you've just outlined, we're talking normally about one or two systems. One of the one of the challenges that I see, especially in the aerospace industry, is that we could be dealing with ITAR, we could be on US GovCloud, we could have a deployment on Mod Ice, we could have deployments where data sovereignty, as a national data sovereignty matters. We could be working in situations where we have end-tier supplier integration issues, and we could even still have people using pen and paper. So
And
whenever
don't
you
forget
talk about
nowadays, we even have deployments in outer space. So we have people working at the edge out in outer space and in satellites developing data and streaming that live too. So the environment is getting more and more complex.
Yeah, and of course, like you say, when you start talking about space, we will delve into that in a few moments, but you're also then looking at moving data in a way that you're able to understand exactly which data source it's come from. You've got all your normal OT problems, satellite one have taken a picture of the target. How do I assure that it's being passed through all the other satellites to the ground? But the thing is, it gets really complex very quickly. So AWS, I know, has security as job zero. So, given the challenges that we see with state actors proactively targeting civil infrastructure to include aerospace and the sorts of infrastructure that space based systems are designed to support in the first place, how does AWS tackling security as it pertains to the aerospace sector?
It's a great question, John. I'm really glad you asked that because, as you said, security is 100% job zero at AWS. So everything we do is anchored in what how do we enable the customer to provide the most secure environment for their particular industry, for the geography they're operating in, and things like that. So we have a whole system of guidelines and recommendations we work with customers to allow them to uh, encrypt their data, to provide data residency strategies. So, for example, I talked about Safran. If you want to keep your data in the French region, you can anchor that data in France and stay and keep it in France and not have it transfer to other countries and things like that. If you're a U.S. customer that has to comply with ITAR laws and rules, you can use AWS GovCloud, which is a fully U.S. citizen supported environment, to anchor all your data in there. Even to the point where if you are a defense customer who has controlled data at the IL5 or IL6, which is secret, top secret levels, we have environments for that type of data as well, very specific to that use case. So we're very familiar with understanding how to work from a security perspective, but also from a compliance perspective and how you report up to the regulators, because compliance is becoming a more and more pressing issue. As the U.S. government rolls out their CMMC model and other countries roll out similar cybersecurity attestation models, it's important for us to work with customers to provide clear visibility for how our environment complies with those models, and then how we can make it easier and cheaper for companies to comply with those certification processes than they would have on their own. Because as you know, John, a large customer that probably has a deep legal team, a deep compliance team that can help work with all those types of models. So, for a customer like Lockheed or Airbus or Boeing, they have compliance teams and understand how to do that intimately, and they're integrated with their government customers very deeply. But when you start to click down to some of the suppliers, a lot of those companies are small businesses that, they may not even have an IT department. They may have somebody who's good with computers that runs their systems, but they still are required to comply with those certification processes, particularly in the defense environment. And what we don't want to see is that those regulations start to become so burdensome and so hard for customers that it drives them out of the industry altogether. So what we've provided for a lot of those customers, particularly to CMMC, is a landing zone environment that allows sort of an easy path for customers to adopt CMMC requirements and become compliant out of the box on day one, and then provides a model for certification and attestation to the regulating agencies to allow them to continue to keep up with regulations, that they don't have to invest in all that infrastructure on their own because they know AWS has it from our perspective as well.
Right, now I've got two follow-up questions in that area. The first one I want to turn to is space because you mentioned it first. So we often say aerospace, and the natural inclination is thinking your F-35s, your Boeing 737s, and those sorts of areas. But increasingly, space is no longer a realm of sci-fi. It's no longer a realm of pure military actors. We now see civil companies placing robots on the lunar surface. We see aspirations with Amazon itself launching hyper satellites at scale into space. So one of the things that strikes me, and I look for your insights into this, is that the way that we used to manufacture space-based systems in the past, of one system, specialist teams, everybody in white coats, dedicated to the building of these bus-sized units, really can't be the way that we get to 3,600 and whatever number of satellites being launched within a very short space of time. So how is the space manufacturing capability being compelled to adjust, maybe taking best of breed practices from automotive or others? How is it being compelled to adjust in order to achieve low cost, scalable manufacturing, or should I say lower cost, scalable manufacturing?
Yeah, I think it's not just space, but we see this emerging domain of urban air mobility with companies like Archer and Joby Aviation. So, those companies have business plans that don't require them to build 50 or 70 aircraft a month. It has them building thousands of airplanes a year, because what they want to compete with is sort of the Uber black market of the world, and luxury or semi-luxury transportation. So when you talked about operating at scale at that level, you have to not only increase your output, but you have to do that at an affordability level that means a ride on a Joby aircraft won't be only reserved for the super rich. So what we've seen that a lot of those customers do is start to sign partnerships with automotive companies, whether it be like people like Toyota or Stellantis, to bring in not just best practice techniques, but also a lot of the actual manufacturing capacity and things that those automotive companies have learned through decades of high volume production. And so what we're seeing those companies start to do is leverage each other's knowledge base, the innovation that's coming out of UAM teams with the manufacturing excellence that comes out of automotive. So you're seeing that more and more and more happening. I expect that to continue.
That's a fantastic. I love this sort of cross pollination of industries in that way. Now, one of the other things that you mentioned, which is as a small business owner myself, I'm very appreciative of AWS for, but maybe you can just double click it for us. One of the barriers for small businesses entering into any contract, either with a large OEM or with defense, is often regulatory compliance. So how can small businesses leverage AWS in order to achieve at least some of that assurance without necessarily having to invest so very heavily in building it all from scratch?
I think that's the key success factor of becoming an AWS customer is, as you said, a lot of companies don't either have the cash or the knowledge or about how to build that infrastructure, and it probably isn't what they want to spend their time doing. They're looking to innovate on a product level, not to have a compute infrastructure that's the most compliant in the world. That's just not their core competency. So what AWS does is provide a fully secure infrastructure and compliant infrastructure of the cloud itself. So all of our data centers, all of our servers, all of our networking protocols, all of that has already gone through rigorous testing and certification by those bodies. And you can check on our website, the various levels of compliance that we represent. And then we help coach customers on their responsibility to secure their data in accordance for those regulatory bodies as well, because that's their responsibility, is to understand how they leverage and use their data. So we have a lot of free training availability. There's a lot of blogs out there that customers can learn and leverage and easily deploy those security techniques to comply with whatever the particular regulatory agency they need to follow in their geography and industry may be.
Outstanding. Well, thanks for that,
And
Tim.
that's
And
that's true
look,
all the
stay
way
with
down
us.
from companies, enterprise down to very small 1-2 person businesses. They may be operating on a free tier from AWS as well.
And it's important to recognize that final comment there from Tim, that it doesn't matter whether you're the world's largest company or the world's smallest. AWS is unusual in the hyperscaler world because the account teams are leaning out, they're helpful, and they want everybody to be supported. And what is more, most of the training, whilst it can be sometimes challenging to find, the truth is most of the training is on the websites, is in blogs, and the people within the business are genuinely approachable and more often than not willing to help. So, Tim, maybe you can help me understand because it's not just that people have to phone AWS. How do people get help from AWS whenever they're thinking about starting in this space?
As I said, one thing, John, we have thousands of partners that are available in every geography. So if people want to work with a local partner to help them get started, if you look at our AWS marketplace, there are thousands of partners out there to help you get started with things. With might be individual small consulting firms, they may be software vendors, they may be larger companies that are helping companies on board or provide training or resources out there. So it's not just AWS; it's the entire AWS community that helps bring customers to the cloud and help them innovate.
So, from connected aircraft to AI driven maintenance, we're going to discover how AWS is shaping the next frontier of aerospace innovation with Tim's insights. As we look to the future, the aerospace industry stands, I think anyway, really on the very edge of unprecedented aviation. This has been driven from advancements in cloud technology. And in our final segment, we're going to explore how is AWS at the forefront of this transformation, enabling developments in connected aircraft, predictive maintenance, and sustainability practices. Tim will provide some insights into the emerging trends that are, shaping the next frontier of aerospace innovation. We're going to discuss how our cloud technology is not only enhancing current operations, but I think also more importantly, paving the way for groundbreaking, changes in how we design, manufacture, and operate aircraft. So, Tim, looking ahead and envisioning cloud technology shaping the future, what do you think are the current trends? What are those things that are happening that are truly transformational within the aerospace industry?
John, I think one of the most exciting things right now is the explosion of connectivity options. Maybe I shouldn't use the word explosion in connection with aerospace, but
I don't.
the growing number of connectivity options that we haven't seen before. So, as a lot of people know, we just launched our first set of Kuiper satellites that'll increase, ubiquitous connectivity. But airlines and air, airplane OEMs are looking to increase that connected ecosystem for what the airplane can do. So when you think about how much data a A350 or a 787 generates on an individual flight basis, whether it be from sensors on board aircraft engines or actuators and things to show how the aircraft is performing and send early signals to mechanics on the ground to optimize maintenance cycles, optimize opportunities like that. Think about things that might be embedded in sensors that might be embedded in stow bins. So as as the passenger boarding an airplane, a gate agent gets an early signal to understand that the stow bins are starting to fill up so they can start to check bags early in the boarding process instead of, I'm sure everyone's been in that airplane corridor when somebody's trying to swim upstream with the rollerboard because there's no room at the back of the plane and they have to check it up front, and how much time that adds to the gate. Think about things like smart galley carts transmitting catering options down to the ground live in real time so that people understand, so that food and things can be pre-positioned for when the airplane lands so that can optimize that turn time. Because from a commercial airline operator's perspective, anytime the airplane's not flying is dead revenue time. So anything you can do to optimize, to speed up that time on the ground is really critical. And then from a passenger experience standpoint, how many times have we all sat in an airplane staring at that seatback entertainment wondering, why can't I stream? Why can't I just watch what I want to on Netflix today? Why am I limited if I'm on a wide body international flight and the flight attendant brings the shopping trolley around and there's your 2 dozen bottles of liquor and maybe some cigarettes and some other things around? Why can't I have live streaming shopping options that allow me to you know shop right on the airplane and have things delivered to my hotel when I land at the gate? What are the types of things that can do that? So when you think about what the increased connectivity can do to the entire experience of air travel and aircraft, I think we're seeing some really exciting opportunities happen at the airline level, at the OEM level, and at the maintenance level. So that's one of the most exciting things to me from there. And then I think that, going back to supply chain, I think what we're seeing from both Boeing and Airbus as they start to push airplane production to volumes that we haven't seen before, that's going to force levels of innovation that we haven't seen in airplanes production. Because to get to 75 airplanes a month, to get to 60 airplanes a month, you can't continue to just work faster, do things the same way you have been doing, particularly when you're talking about a challenged and smaller workforce. So the interest in learning how to use things like the technician assistant I talked about before in terms of putting Gen AI at the point of use that optimizes the mechanic's experience and allows him or her to leverage what might be a small amount of knowledge that they have from their direct experience, but taps into you know almost generations of knowledge that the company has before is really unprecedented. So I think we're really at a really exciting time for innovation in aerospace, and I'm looking forward to what our customers will lead us into.
So and I love the way you set out the, again, it's a data challenge, right? You show the sharing of data, the connectivity, like we see in the automotive world, right? Whenever my car has got a problem, it's already communicated with the garage. I'm able to upload a video of the car making the squeaky noise whenever I can get it to do it because no mechanic can, so that they can listen to it and they can get an idea of what's going on before they arrive. But a lot of that, though, it can be challenging, and maybe you can sort of just give an extra level of detail on this. So, for instance, I may have chosen to purchase the aircraft but rent the engines, or I may have chosen to purchase the entire aircraft and the engines and therefore intend to maintain it myself. And those different sorts of models, and the same for catering, the same for the luggage story, those sorts of models mean that I'm either more dependent on provision of engine maintenance as a service or baggage loading as a service or gate management as a service. So therefore, the ability to share data from the aircraft in transit to all of these agencies then becomes really tough. So what sorts of ways are innovative companies thinking about that ability to share, information seamlessly and meaningfully with their various partners in that space?
I, I think you need to start with what you said just a few minutes ago in terms of the volume of data that's coming off that airplane. So if it's streaming from an engine, streaming from a galley, whatever it is, the amount of data that's being generated on an airplane is probably vastly greater than what elements of that data are actually useful. So if an engine, for example, is performing as expected and it's operating with its normal constraints, do you really need to pay to stream and analyze that data real time, or do you only want it to understand what are the anomalies and where do I need to focus on that? So that's the first thing, is to understand what are the type of edge compute areas that you want closer to the airplane, closer to the point of use to detect where are anomalies as opposed to standard data elements that, frankly, you could look at in batch or look at for trends over time. You don't need to see that data in real time. So that's one of the first things that people need to understand. And then I think the other thing is, if you have to look at how do all does this data come together in a common environment to understand what decisions do I need to make. So, Airbus has been very I'll say at the forefront of a lot of that discussion through their Skywise platform. So they provide an environment that brings together data from multiple uh, parts of the airplane, so that an airline can immediately see what's happening on board its airplane. They can make decisions around uh, maintenance cycles, on repair cycles, and things like that, because they're integrated into that Airbus Skywise platform that has inputs from various suppliers as well. GE Aerospace is another company that does a lot of that type of work of bringing data together and allowing companies to understand what's happening with the engine and when do they look at various maintenance cycles and spare parts and things around that.
Excellent. Now, just switching a gear a little bit, it's kind of gone out of fashion a little bit in the last 100 and something days, but I just want to touch base a little bit on sustainability, if I can. So, the aerospace industry, and it's not just the obvious, use of fuel, etc., but more widely, the aerospace industry is heavily criticized, as is aerospace travel and space travel, heavily criticized for sustainability challenges. What is AWS doing to help customers, in that space understand the sustainability issues that they have and maybe helping to address some of them in a meaningful way?
Yeah, and I'll challenge your first statement that sustainability may have gone out of fashion. I think regulatory environments and government policies may change, but certainly from a customer behavior standpoint, what customers are expecting out of airlines and the aerospace industry continues to be that they want less impact on the environment, lower emissions, lower fuel costs, which drives ticket prices. So those I don't think have changed. I don't think they will change. And we still see strong commitments from all the major players in the aerospace industry, whether it be a company like Airbus that's aiming for net zero platforms, whether it be a company like beta who's just at the beginning of their life cycle, essentially developing a fully electric airplane. So the sustainability goals, I don't think have changed. Now, in terms of what that means for AWS, so if we look at two companies, so if we look at a company like Collins Aerospace, for example, who's a major avionics provider, they have a system called FlightAware that uses AWS technologies to, in real time, provide recommendations to a pilot on flight path optimization to do things like avoid weather, turbulence that may be unpleasant to the passenger, but also how do they maximize fuel efficiency and emissions burns. Now, the decision on whether to take those recommendations is still 100% in the pilot's hands. So the we're not taking any of the human decision making out of that, but it's giving that pilot real time feedback and real time opportunities to say, here's opportunities to save fuel and things like that. Qantas Airlines took that same challenge a few years ago with AWS, where they took a lot of their data that they had historically on things like takeoff and landing angles at flight paths, and what were the types of things they could understand to minimize that fuel burn. And they were through AWS, they were able to come up with a model that reduced their fuel costs by 2% across the board. And 2%, when you just look at it from that standpoint, might sound like not okay, 2% is not 100%, but when you think of how much an airline spends on jet fuel and the variable costs associated with that, it's really significant savings to a company with the fleet size that Qantas does, or when you extrapolate that to what might be the potential for even all larger airlines.
It's fantastic. And I'm glad to hear it hasn't gone out of fashion. It's certainly not my experience of any companies we're dealing with that there's been a sudden change and a desire to go back to, the bad old days of heavy polluting and non-sustainable businesses, which is great news. Now, if we look at another area, if we think about something like banking, small challenger banks have come along, cloud native, all innovative, and they have challenged to the absolute root of some of these larger, more traditional banks that have become unstuck and are find themselves in catch-up mode. So how can small companies that are out there that are thinking, I want to enter this market, I'm going to go and disrupt this market. You've given some examples of some of the sort of urban transportation companies. How can you leverage AWS to sort of gain some of that competitive advantage to become a genuine disruptor in this area?
Yeah, I think this is really a key advantage to the cloud and to digital innovation, particularly the world of digital engineering. So, the insurmountable costs of designing and building an airplane used to really get anchored in aircraft development. So, you do your design, you'd build an airplane, you'd fly through a wind tunnel, you'd fly through a bunch of prototype tests. They're all incredibly expensive, and for a lot of small companies, in some cases, bet the company flights in a lot of ways. What we've done with, again, going back to companies like Joby and Archer or Boom Technologies, who's bringing back supersonic flight, is help those companies do a lot of that uh, computational fluid dynamics and that early stage flight design in the cloud itself. And what has historically been the challenge there is you had if to do those types of high performance compute simulations required a huge investment in compute power that you might only use for a relatively short period of time, and then all that investment you have would essentially sit idle. So by moving those workloads to the cloud, and we work with partners like Siemens, for example, to allow companies to do this, they're able to leverage the pretty much unlimited compute capacity that AWS has to run those simulations, to understand what those simulations look like, and to adapt their CAD designs, their CFD designs, and run their PLM systems fully on the cloud without having to make those investments up front before they are ready to invest cash. And then when companies start to look at doing things like full stage prototype flights, they're starting to run live data streaming from that airplane into the cloud, so they can see in real time how various systems on the airplane are behaving, and how does that affect the actual flight, or how does that differ from what their expected results are. So it's, again, seeing that real time, and they're leveraging that expandability and elasticity that the cloud provides without having to make those compute investments themselves, and they can take that cash instead and channel it into the actual airplane itself.
I love the way you said at the very start of this conversation that it's all about the aircraft and people's experience of the aircraft. So that ability to channel the cash back into the aircraft seems like a fitting way to sort of wrap some things up. But Tim, look, you're
I
the
mean, just think
expert in
about
all of
the
this.
type of we're talking about in the industry now. We're talking about air taxis that people have been talking about for years. We're talking about supersonic flight returning. We're talking about unprecedented capabilities in the defense sector. So we're really at a cusp of innovation in the industry that is just so exciting to be working with right now. And what customers are bringing to us, what we're learning from our customers, just provides so much energy to my team as well. So it's great to have this sort of uh, back and forth relationship with our customers to understand what truly is innovating in the industry.
I'm going to put you on the spot, Tim, and say that we're going to come back and talk, hopefully, about the defense sector in a bit more detail, because everybody is very curious about how aircraft are increasingly being used as sensors, how drones are fundamentally changing how people think about air-based platforms, how low cost, if I could put it that way, low cost units are taking down very expensive traditional ways of thinking about air defense, etc. So I would be, very much keen if we can do that in a separate call, and I think it'll be exciting. But here's the thing, Tim.
Well, it
I'm
depends on
actually
geospatial analytics and what that's bringing to, whether it be private operators or government operators that are bringing to adjacent worlds, things like agriculture and uh, engineering and construction, the availability of geospatial data and how much you can process what's happening in real time through now these networks of LEO satellites is really unlocking a crazy amount of innovation as well. So that'd be a great conversation to have, John.
outstanding. That so look, I'm gonna give you the mic for the moment and say this, that look, I've asked you a whole bunch of questions. They're from me, the areas that I was particularly keen to understand and what people who watch the channel were posing before we jump on this call. So maybe you could take the mic back for a moment and think, what question didn't John ask me that he should have? So what are those things that you really want to highlight to people watching who are particularly curious about the use of applied technologies in the aerospace environment?
Yeah, I think the most important thing is that we have transitioned from a world where cloud was an IT-led discussion to now where cloud is a fully integrated business discussion. So while IT will obviously be involved and needs to be part of that discussion, what we really see now is more and more business leaders, whether that's heads of manufacturing, supply chain, passenger experience, connectivity, any of those things, starting to challenge what can AWS and the cloud bring to help them enhance their bottom lines, grow their revenues? What is unlocking data and do to monetization opportunities in their business? So it's really important that line of business leaders think a little bit about what does cloud do for them, as opposed to it being sort of, well, that's the IT organization that does stuff that used to be called servers and now they're in the cloud. The discussion is much more a business centric and a business led conversation right now, with IT being a critically important partner. So that's the most important thing I think that we want to continue to help our customers understand.
That's fantastic. And it's look, there's a whole series of videos out there, guys, that we've done quite recently where we've posed questions such as, if your supply chain leaked like this, you'd be sacked. And we've used that as a way of talking and exploring how our business leaders need to, treat cloud spend and treat cloud utilization like any other asset across your entire platform. You need to be, you don't necessarily need to be able to program in Python, but you do need to understand cloud, and you do need to understand how the cost drivers in cloud impact your bottom line, and more importantly, how to leverage that in order to enhance your profitability. So if you've enjoyed watching this, then please, throw some comments in. We'll get Tim back on another call. We're going to be discussing defense and geospatial and all other stuff, but I'm very happy to bring the questions back to Tim. Tim, thanks very much, mate. It's been an absolute pleasure having you back on the channel, and we look forward to staying in touch.
Thanks, John. It was great talking to you.